In this video, we'll be talking about the reciprocal function. The reciprocal function is written as 1 over x, so just the reciprocal of x. Reciprocal means upside down, sort of. Um, and the function, this basic one, just 1 over x, looks like this. And part of what we're interested in this video is how do we change this function a little bit so that we can shift it left or right, or maybe up and down. There's a couple more ways I could think of transforming it, but I think what's usually covered in like a high school class are those two transformations. Uh, okay, so first of all, let's notice that when x is positive, the bigger x gets, 1, we get 1 over some really big number. That number x goes up to 50 trillion. 1 over 50 trillion is really small, but it's still a little bit above 0, and you're never going to get all the way down to 0. So in math, we call that asymptoting. So it asymptotically goes to 0, but it's never going to reach 0. Okay, it goes all the way out to x equals infinity, and it'll still be a little bit above 0 all the time as we go this way. Now, when x is positive and x gets smaller, now all of a sudden we have 1 over some really small number. That's big. So like 1 divided by 0.00001, that's going to be a bigger and bigger number. As x gets really close to 0, this just shoots up to infinity, and x can never actually be 0. Because when x is 0, you get 1 divided by 0, and that's always a problem in math. It's just called not defined. This cannot be done. Um, so you can see this curve. As x gets big, it approaches 0, but never gets there. And when x is positive, but getting close to 0, 1 over x goes up to infinity. And these are these two asymptotes. So there's a line, the vertical line, that never gets touched right at x equals 0, and we have this other one at y equals 0 that the line never touches. So the curve is boxed in here. It tries to get as close as it can to that vertical line and the horizontal line, but it never touches them. Now when x is a negative number, it's a similar story. X becomes, goes to minus infinity. 1 over that will get closer and closer to 0, but it'll never quite touch that line. And as x goes to 0 from being a negative number, getting a little bit complicated here, but basically we've got these lines here like this that never get crossed by the function. No matter what x is. And there's this value of x is not allowed. That's at x equals 0. And the y value of y equals 0 never gets reached for any x. Okay, so we could actually put that on our graph as well. These two lines, I could say there's an asymptote at x equals 0. So that line will never get reached. And y equals 0. Also is never touched by that reciprocal function. Okay, now what if I want to move that function up a little bit? It makes sense. I could just, if I add 1 to it, I'm going to shift all the y values up. You can see that function jumped up on my screen when I typed in the 1. And now the line that will never be reached is y equals 1. It's this, this still behaves the same, but now I added this 1 to it. So while this can get as close as possible to 0, but never reach 0, now when you add 1, the overall thing will get as close as possible to 1 and never reach the 1. So let me type in that line into my software here. Again, okay, there we go. Okay, so y equals 1 is our asymptote this time. I'll turn on the plot. Oh, that didn't be a 1 yet. There's the 1. Okay. And still x equals 0 is the line that doesn't get reached vertically. Okay. And, if maybe I'll do this in a better way in a second. But if I add 2, of course, I shift the whole thing up 2 instead of just 1. So compared to that original plot that was centered around 0, this one is now up 2. All right, so let's get rid of those vertical shifts. How about horizontal shifts? Now these horizontal ones are backwards of what you might expect. So if I go and add 2 on this denominator, so instead of x, I've got x plus 2, which way do you think it will shift? It shifted left. That's a little bit weird, right? The thing is, the point where the denominator is 0 is now given at x equals minus 2. So where the way the curve looks now at x equals 0, see at x equals 0 is where that asymptote is. Now the asymptote will be at x equals minus 2, because it's the minus 2 that makes that bottom go to 0. So you can see it shifted left to minus 2, not plus 2 like you might assume. And of course, so a shift to the right, I need to put in a minus sign there. And then you can see it shifts the plot to the right. Okay, so let's put all of this together. Instead of using specific numbers, what if I say this is x minus, let's try h. I think that's what's usually used in the classroom. It doesn't matter what letter you pick, really. So I'll call that h and k. My software might complain about that, though. Let me put in now what h is. So let's say h equals 0, and let's say k equals 0. That's not what I want. Okay. We're going to make that a slider there. This is a slider too. There, so this way I can change the value of h and k. I kind of lost what I typed in before. Let me try that again. Okay, so now I can change that horizontal shift and the vertical shift with these sliders. Notice I put in the minus sign there because the horizontal shift is backwards from what you might expect. So now when h is, I can make h 2, that shifted it to the right when I change h from 0 up to 2. And I can shift this whole thing up and down with making k different values. So the numbers that go in the reciprocal function here and here end up causing those vertical and horizontal shifts. Importantly, the horizontal one, the left-right one, there's this minus sign there. Okay, so x. So right now, well, you can see what's the current version of the function is based on where the sliders are. So x minus 2 is actually shifted 2 to the right from when h was 0. So when h is 0, one more. There we go. That's back in the center where we started. And when I change h up to 2, you can see it got shifted to the right, and I'm subtracting the 2 in that function there. So that number that goes beside the h in, I keep moving this thing when I don't want to. The number that goes beside the x in the denominator, that's your horizontal shift. This number here all by itself is the vertical shift. The vertical shift is pretty simple. It goes up and down depending on what this number is. The horizontal shift is also simple. It's just that it's opposite of what you might naively expect. So you subtract 2 and that ends up shifting to the right. Whereas this, if if k was negative, that would shift it down. So it's maybe a little bit, well, the thing to remember is the horizontal shift is backwards from what you might think. And that backwards part comes from that being a negative sign instead of the positive sign there. All right, so that's everything about reciprocal functions and how to shift them around. Leave any questions you have in the comments.